Supreme Success Academy online lectures. Don't forget to subscribe to this channel and share this video with your loved ones. Today I will be taking you projectile motion. This is in continuation of motion that we started some times ago. We have treated linear motion, and I told you that linear motion can be in two ways, either vertical or horizontal motion. But projectile motion is a motion that undergoes both vertical motion and horizontal motion simultaneously. This is what makes projectile motion different from the linear motion. Linear motion is a one-directional motion, while projectile motion is a two-dimensional motion. By definition, we can define projectile motion as the motion of an object whose trajectory path is parabolic in nature. What do we mean by parabolic? That is like this. It has a curved path. So before an object can undergo projectile motion, that is, it can be moving both vertical axis and horizontal axis simultaneously. That object must be projected at an inclination. That is, there must be an angle of projection. The angle, if your angle of projection is 0 degrees, then you are going to have horizontal motion, not projectile motion. If it is 90 degrees, you are going to have vertical motion, not projectile motion. But if the angle now varies between 0 and 90, it can be 1, it can be 2, it can be 3, it can be 4, and so on and so forth. You have it called projectile motion. Such a velocity, or for an object, we have the vertical component and we also have the what? The horizontal component. So this is what we mean by projectile motion. And we have different types of objects undergoing projectile motion. You can imagine it to be like you kick a ball that now move up and it land. Or it can be like you are playing your lawn tennis. These are different examples of objects undergoing projectile motion. And we have some object that undergoes half of projectile motion. It can be you are standing on a cliff and you throw an object forward. Then the object will go and it will come down like this. This is also a case study of projectile motion. So then the next thing you need to know are various terms that we are dealing with under projectile motion. Number one term you need to know is what we call time to reach maximum height. Please permit my abbreviations. Time to reach maximum height. We use small letter t to denote this. Number two, we have what we call time of flight. This is the time taken for the object to take off and to land. We use capital T to represent it. Then the next one we have what we call maximum height. Maximum height. This is the maximum vertical distance covered by the projectile. Then we have number 4, we have what we call your range. Range, we use capital R to represent the range. We call it maximum horizontal distance covered by the object. That is range. So it's very important you know the formulas for all these terms we are using under projectile motion. For your time to reach maximum height, the formula is T equals U sine theta over G. Your U is the initial velocity. Your theta is the angle of inclination with which the object is projected. And your G is, of course, your acceleration due to gravity. It's a constant. Then your time to reach maximum height is times 2 of time. Your time of flight is times 2 time to reach maximum height. That's 2U sine theta over G. Then your maximum height is given by U squared sine squared theta over G. And your range, of course, is given by u squared sine 2 theta over g. Now, there is another important thing you need to get here. That for this range, question we ask you, under which condition will your range be maximum? For your range to be maximum, that is for your object to undergo a maximum horizontal distance, your theta must be 45 degrees. What do we need? Look here. If we say r equals u squared sine 2, you substitute 45 here. Then you have your what? G. Then this is going to be 90. Then you have your u squared sine 90 degrees over g. Sine 90 degree is 1. So if you are doing sine 45 degree, sine 70 degree, sine 30 degree, sine 20 degree, is going to give you value less than 1, which is going to make your range a reduced value. But if your sine is 1, it means the range is going to be maximum. So for your maximum range, you will have u squared over g as the formula. So you get this when your theta is 45 degrees. So the next thing I need to do is to give you questions, exam questions on projectile motion. There are some questions you will see in projectile that you just substitute. Just know the formula that your t small t, time to reach maximum height, is u sine theta. You just substitute straight. But there are some questions that you will not be able to substitute directly into equation. You need to think on how to go about. In fact, you will not even use any of this formula to solve such a question. I'm going to give you 3 questions and I'm going to treat them for you. Then if you have any question you come across while you are trying to read more on this topic and you don't understand, you can put them in the comment section. Some of our team are going to respond to your question. So if you have any question, just comment it in the comment section. So let's try to solve these 3 examples I have for us this afternoon. Solution. Don't forget the 5R principle of solving problem that I gave you some time ago. 1, read the question. A stone is shot from a catapult with initial velocity of 30 meters per second. Record what you are giving. Initial velocity u 30 meters per second. At an elevation of 60 degrees to the horizontal, that is your theta equals 60 degrees to the horizontal. Find the time of light. We use capital T to represent that question mark. Find the maximum height. That's H question mark. Find the range. How question mark. So you have read the question, you are reasoning it, then the next thing you need to do is to relate it together. I've given you formulas to do that. What is the formula for your time of light? That's 2u sine theta over g. So you have your 2 times initial velocity, 30, times sine 60 degree over g. So your g, we've said I use your g to be what? To be 10 meters per second. Your sine 60 is 0.866 times 20 divided. You just use this to cancel this times 6. Then you get your answer using your calculator. Your maximum height. Your maximum height, you have u squared sine squared theta over g. Please, you need to be cautious here with your sine square theta, 30 square times sine. Just write your 60 all in bracket and put square here over 10. So use your calculator to get this, then you have your answer. Then the next one is your range. The formula for range is u squared sine 2 theta over g. Your u is 30, then you square it times sine 2 times your theta, which is 60 degrees over 10. Then using your calculator, you get your answer in meters. You get your answer for this guy also in meter. your answer for this guy will be in seconds. So that is that about the first question. This is just straightforward. You substitute your parameters directly into the formula. Let's look at the second question. Second question is a bit technical. Just a bit, not that technical, just a bit technical. Look at it. A missile is projected so as to obtain maximum range. Don't forget that. I gave you condition for what is happening at maximum range. Can you remember the condition now? What's the condition? Good. Your theta at maximum range, theta equals 45 degrees. That's the key to solve this question. Calculate the maximum height. We are looking for maximum height if the initial velocity of projection, u, is what? 200 meters per second. So what's the formula for maximum height? Can you remind me again? H, yes. U square, yes. Sine square theta over g. Now, if you don't remember that theta equals 45, the question did not mention that. They just told you that what? At maximum range. So if you don't remember this, there is no way you are going to be able to solve this particular question. So just put your u, 200 square times sine square 45. I said you can just write this as sine 45 and put square here over g. So you have your 200 square to the 4,000 sine. You just operate this times sine 45, square it, divide it by 10. You get your answer in meter. So the key to solving this second question is to remember what is happening when an object is undergoing maximum range. Now the last question. The last question is totally different from this previous two. These are set of questions that look somewhat technical under this topic, projectile motion. But I'm going to make sure you understand it. I'm going to take it bit by bit. Just follow me. A body is projected horizontally from the top of a story building. Let's take this as a story building. It could be Cocoa's building in Ibadan. And they said that it's projected horizontally. Just indicate it. That's your horizontal velocity. A building, the height of the building is what? 80 meter high. 80 meter high. With a velocity of 20 meters per second. This is the velocity, 20 meters per second. And I told you when you are recording your given information, you can use diagram to make you have visual understanding of what is going on. The question says, calculate the time taken to fall. This object will go and fall like this. So, what time do you fall? Now, you will be tempted to say you are using t equals to u sine theta over g. But if you look here, you are not giving theta. So, you can't use this formula. The next thing, the question says, calculate what? The vertical component of the formula. We have not mentioned anything about that. And lastly, the question says, find the distance, from this to this. We can say this is the range. Of course, you use your range equals to u square sine 2 theta over g. You still have the same challenge. Theta is not given in the question. You can't use this formula. So what you are going to use is still your normal linear equation of motion. But just follow me. Just say, using S equals to ut plus half at squared. This is your vertical distance given to you. Just now say, all right, we want to say considering the vertical component of the motion. Please, I'm going to mention some salient facts now. For vertical components of this motion, your S will be height of the building, and it's going to be 80 meters. That's first point. Your vertical velocity, uy, once the object is projected horizontally, Not like previous question that it was projected at an inclination. For such an object like this, you are going to have vertical component velocity, you are going to have horizontal component velocity. But this question is direct. The object is projected horizontally. Therefore, the vertical component of velocity is 0. It doesn't exist. Then, take it as the second point you need to know. And the third point you need to know is your acceleration due to gravity. For vertical component, acceleration due to gravity, the object is falling under gravity. In such a case, you say your G is what? 10 meters per second square. Now, let me take you to the next important thing you need to know. Considering the horizontal component of the motion. What is happening in the horizontal component? Your distance is the range. Horizontal distance you are asked to find. Good. For your horizontal component, your velocity, u of x, velocity is going to be 20 meters per second. Then the next thing is your acceleration due to gravity. Acceleration due to gravity doesn't act in horizontal direction. It only acts vertically. So in such a case, this is going to be 0. Then we cannot substitute. Let's now look for what did they ask you to find. They ask you to find your time. You can just substitute in this equation using this vertical component information or use the horizontal component information. But let's just use the vertical component information. So we want to determine the time taken for the fall using s equals to ut plus half at squared. Your s, we said for the vertical component, is 80. Your u is 0 plus half. Your a is 10. And here is the t we are looking for. So you have 80 equals 5t squared. Divide this by 5. You have this equals to 16 equals to t. So your t equals to root 16, which is 4 seconds. That is your time taken. That answered the A part of the question. Then the distance part of the question. From the foot of the building, say ut plus half at squared. Consider the horizontal component. The range is an horizontal distance. So you use the horizontal component. S equals to r. Your u is 20. Your t, you've gotten it here to be 4. Plus half a, don't forget for horizontal component, is 0. Then your times your 4 square. All the time here becomes 4 plus 20 times 4. That's 80 equals your range. So your range is 80 meters as the answer. So please, if you come across any question you have challenge with, just put them in the comment section. We are going to respond to that. And also, I'm going to put some practice questions there for you. Please solve them, then scan them. I'm waiting for your solution. I want to see how well you are following all these tutorials. Thank you. See you next class.